Okay? So, iba yung materials na to, but it is similar to that one. So, we're talking about the so-called electronic structure. Okay? And when we're talking about this electronic structure, the first thing that comes to our mind is yung tinatawag nating light. Okay? And the nature of light, as we know it, is usually that of what we call a wave. So, bago natin i-discuss yung dual nature, light is known to behave like a wave. Okay? So, a wave, we could say, is just a vibrating disturbance in which energy is transmitted. Okay? So, saan nyo ba ma-observe yung wave? So, let's say you are in a pond. Okay, pag may pinato kayong rock doon or pebble, so you will see, okay, na magpo-form ng wave. And if you're going to look at the side view of that, ganito yung itsura niya. Although, ang makikita natin is parang pag ganon, tapos magpo-form na ganon. But if you're going to make it like this, you form this thing. And usually, okay, you can characterize yung tinatawag nating wave. Okay? So, the characteristic of this wave can be through the length, yung tinatawag nating wavelength, which is just the distance between the identical points on successive wave. So, kung meron tayo dito sa peak, we look at the distance of the next peak. So, kung meron tayo dito sa trough, we're going to look at the distance. So, it's just the same, we could say, point ng wave ang tinitingnan natin with respect to wavelength. Okay? Now, if we're going to look at the height, yung vertical distance from the midline of the wave to the peak or the trough, ang tawag natin dyan, amplitude. Okay? But amplitude does not characterize a wave. The one that characterizes a wave is the wavelength, okay? And the other one that is known as what we call the frequency. Okay? So, the relationship of the wavelength and the frequency, we could say, is inversely proportional. Because when we're talking about frequency, that's the number of waves that pass through a certain point in time. Okay, usually seconds. Kaya ang unit na inaano natin dyan per second. Or yung tinatawag nating hertz. So, when I say inversely proportional, so as you could see here, you have a longer wave compared to the one here. So, the number of frequency is less. Because if you're going to count at a certain point in time, ilan lang yun? 1, 2, 3, 4 frequency. Okay? But if the wavelength is shorter, the frequency is higher. So yun yung relationship ng dalawa. Okay? So we could say, if we have what we call this one, okay, and you multiply it with this one, ano makukuha nyo? Anyone? Wavelength of frequency is equals to what? You can use your voice, okay? So you have the so-called speed of light. And the speed of light is what? Constant.
3 multiplied. 3 multiplied to 10 raised to 16 po yata.
Okay, so it's 3.0 times 10 to the 8 meters per second. Okay, now, if we're going to look at this, okay, we could say that the material that we have here is just anything that is the one that has wave-like property. And we could say, we can include this as the so-called electromagnetic radiation. Okay, and James Maxwell proposed that when we're talking about visible lights, it's made out of these so-called electromagnetic waves. Now you may ask, why electromagnetic waves? Because it has both the electric component and the magnetic component. So one we could say is like this, and the other one is like this. But they go in the same direction. And if we're going to look at this electromagnetic radiation, this is just the emission and transmission of energy in the form of electromagnetic waves. Okay, at dito po pwedeng i-ano yung value ng speed of light in vacuum. Okay, so all we could say electromagnetic radiation, the speed of light is just the product of the wavelength and frequency. Now you may ask, what is this electromagnetic radiation? So it's made up of different regions. Okay, and if you're going to look at this, they have application in our everyday life. The main reason why we see the different colors around us, okay, we tinatawag natin rainbow color, is because of the small visible region. It's so small. Okay, now if you're going to look at this one, so we could say this is what going to longer wavelength, and this one is going to shorter wavelength. So from here, we could say, pag tinanong kayo, which color has the longest wavelength? So i-apply nyo yung tinatawag nating Roy G. Bibb. Right? Is this new to you? So, yung blue has a shorter wavelength compared to the red. Now, in terms of frequency, we could say this one has higher frequency. Ito naman, lower frequency. Now, we can relate also the energy here. So, saan marirelate yung energy? I can ask the question, between blue flame and yellow flame, which is hotter or which is warmer?
Blue flame po.
Okay. Have you watched Game of Thrones? Kung kung nakakaintindi na kayo, kung pwede na kayo manood doon sa series na yun. So there's two dragons that fought at the end. Okay? The normal one, which emits a yellow flame, and the one that was resurrected by the Ice King that emits a blue flame. Okay? So between the two, we could say mas high energy yung blue flame. We always had cool blue, right? But it's not really true. It's a misnomer. And the way that you could look at this, what we call energy, so we could say for this one, the energy here is lower, the energy here is higher in this region. Now, what are the applications that we have? At longer wavelength, meron tayong infrared, yung microwave, saka yung radio wave. They're not highly energetic, but they can affect other stuff. Okay, I don't know if you heard reports that some residents who live near satellite feed, okay, they usually have some health problems. But in terms of energy, they're not really high compared to this one. What's one effect of ultraviolet? Yung tinatawag nating tan or sunburn. Okay? That's the reason why you don't look directly in the sunlight. Okay? Unless you're President Trump, who's dumb enough to look in the sunlight during eclipse. Okay, and then if you're going to talk about other electromagnetic radiation at higher energy, shorter wavelength, you have the X-ray. Okay, that's the reason why, as much as possible, once a year for you to X-ray, because you don't want to express to be exposed in a high radiation. And then you can also have these gamma rays. So if you're exposed to that, you're not going to become incredible hope. You die. It's as simple as that. And if you're going to go further there, you have the so-called cosmic rays. And if you're exposed to that, you also die. You don't become the Fantastic Four. Okay, those stuff are just science fiction. So ito yung tinatawag nating electromagnetic radiation. So there's a lot of questions that can be asked here. Okay. So this is very important in the knowledge doon sa electronic structure. Okay. And we can have some calculation here, but the quiz that we have today, wala pang calculation. Ano ko muna kayo, mga true or false question lang. Like 3 questions in 5 minutes na sasagutin ninyo. Okay? So, I'm just going to give you some calculation here, maybe one calculation, and then you can work out the one doon sa module, tsaka doon sa lecture ko. And as you could see, this is different from the lecture material that I have. Parang ginagawa ko na completos recados tayo to prepare you to the exam. Okay? So we can have here, a photon has a frequency of 6.0 times 10 to the 4 hertz. So hertz is equals to what? 1 per second. Or ganitong symbol na to. Now you are asked to convert this frequency into wavelength. So does this frequency fall in the visible region? So if you're going to look at the visible region, so this is small region here, from 400 to 700 nanometer. Okay, so if we're going to solve this, so we have this thing. So anong alam natin? We know C, so we are asked to get this one. So it's just like this. So you have 3.0 times 10 to the 8 meters per second divided by 6.0 times 10 to the 4 per second. Ano yung makukuha nyo?
I times 10 raised to 11.
So you have 5
Times 10
times 10 to the what?
raised to 11.
So you have 3 exponent 8 divided by 6 exponent 4. So 5 times 1, 2, 3. Tama ba? I think I have the thing here just to make sure. Now, this is in millimeter. So you have to convert it to nanometer. So if you're going to do that, so for every 1 meter, you have 1 times 10 to the 9 nanometer. So you multiply it by 1 exponent 9. So you have 5 times 10 to the negative, to the 12. So we could say, based on this, okay, it's not in the visible region. So if you're going to look at this one, the electromagnetic spectrum, so doon siya sa region near the microwave or the radio wave. So those are some of the questions that may come out. So maybe sa next quiz natin, bigyan na natin ng calculation. Okay? Now, all the while, ang alam nila, yung light, okay, talagang ano, wave in nature. Okay? And what happened during that time, okay, yung common na atomic theory, what do you think is the common atomic theory during that time? If we're going to have some sort of a history no atomic theory, I can use thing here. So, kailan nag-ano yung concept ng atom? Anyone? Is it during the Greeks, right? Sino yung natatandaan yung ano dyan? In bold.
Aristotle po.
Is it Aristotle? It's the guy by the name Democritus. Although in some books it says there's another one like Eusebius. It's like a master and apprentice, parang sa Star Wars. But the problem with Democritus, he's not as popular as Aristotle. Okay, so noon pa man uso na, okay, kahit bobo, basta sikat, pinapakinggan nila. Okay, so what is Democritus said? That if you're going to cut any materials, it will come the time that it will be indivisible. At doon na ano yung word na atomos, which means indivisible. But during the time, there's no scientific evidence. It's all speculation. Okay? But unfortunately, kumasikat si Aristotle, so nangibabaw yung ano niya, yung element is made up of 4 materials. Okay? Kung nanood kayo ng Avatar, yun yung 4 na ano dun, yung air, fire, ano yun, yung banda, earth, wind, and fire, kasama doon. At saka yung ano isa, land. Okay? So yung any material is a mixture of that. So kapag alam mo yung Captain Planet, yun yung element nila para mag-form sa Captain Planet. And that's the one. But around 1800, an English school teacher by the name of John Dalton went back doon sa concept na pinupose ni Democritus. At inano niya yung atom. Okay? Sabi niya, atom is what the common element made up of. And he put some postulates of it. Some of them are already discarded. Okay? And then after Dalton, sino yung kasunod? Si Thomson, di ba? Ito naman, yung gamit yung, I don't know, you know, an old TV na ano yung yung mataba sa likod. I don't know if you have seen that. That's an old television set. So, he used this cathode ray tube. Okay? At nakita niya na all of these cathode rays or canal rays is made up of negative, what we call charge. So sabi niya, yung atom, this is made up of usually negative. And he assumed that there are positive particles on it. So meron siyang tinatawag na plum pudding model. Okay? So meron kang pudding, tapos yung mga resins doon, yun yung tinatawag natin negative charge, which we call electron. And this was discarded by one of his students, which is Rutherford. Okay? So ano yung experiment na ginawa ni Rutherford? Marami pang ano doon, kinarakterize nila yung electron, yung the Millikan oil experiment. Okay? But Rutherford, he did this so-called alpha scattering, and it was only useful because of X-ray. And he found out that Thomson's model is not the right model. Because he found out, okay, kapag true yun, magdi-deflect. Okay? Yung alpha rays niya, because alpha rays made up of positive. But what happened is, most of them, 98 to 99% just pass through. Okay? And what we found out there is, yung may massive lang na positive charge doon sa gitna. And that's where you have the so-called nuclear model. So yun yung ano yung time na yun. Okay? So anong problema dito sa nuclear model? So if you're going to look at the nuclear model that you have, during that time, okay, if we follow the so-called classical physics during that time, yung Rutherford atom na yun, unstable. I think I'm just going to use yung PowerPoint para at least maganda yung. So, unstable yung Rutherford atom pag pinapalo natin yung classical physics. Because what will happen, your electron, okay, in circular or elliptical orbits around the nucleus, it must emit radiation. And when it emits radiation, malulus yung kanyang energy at spiral in the nucleus. But the problem is, it doesn't happen. Okay? So yun yung ano doon. So they need an explanation why, in spite, okay, of the behavior of this what we call atom, the nuclear model, hindi siya ma-explain yung tinatawag nating classical physics. Ano ba yung classical physics? Anyone? Physics based on who? Sino
Sa-
nag-propose ng classical physics?
Sa Newton po.
Okay, the Newtonian physics. So pag in-apply yung classical physics doon sa Rutherford atom, ay ito naiinis ako, 10 minutes na naman. Akala ko ligtas na tayo eh. Okay? So the usual, pag kinik out tayo, balik ulit tayo. Okay? So yung classical physics, pag in-apply mo doon sa atom, hindi niya ma-explain bakit stable yung behavior ng material. So, bago ma-explain yun, okay, merong phenomena na na-observe nila na hindi rin nila ma-explain using classical physics. At ito nga yung unang sinolve ni Max Planck. Okay, ito yung tinatawag nating black body radiation. Okay? So, ang ginawa ni Max Planck, when solids are heated, they emit electromagnetic radiation over a wide range of wavelengths. And he found out that some of the radiant energy emitted by an object at a certain temperature depends on its wavelength. Hindi siya yung parang direct. So at a certain, what we call temperature, nag-ano lang siya at a certain wavelength. Okay? So ito yung tinatawag nating black body radiation. And the way Planck explained it is, he described the energy not as continuous but as a discrete unit. So from the wave nature, dito na pumasok yung particle nature. Okay? So ang ano niya dito, yung energy in the form of light, it's emitted or absorbed in discrete units. And during that time, it was revolutionary. And it helped explain the behavior of the atom. So pagpasok niya, nag-develop siya ng panibagong equation. Okay? So he said, the energy of a material depends on a number that he set for times the frequency. At yung H na yun yung tinatawag na Planck constant. Okay, it's 6.63 times 10 to the negative 34 joules per second. Okay? Now, the classical physics cannot explain the behavior of this black body radiation. So classical physics, the object can acquire or lose any amount of energy no matter how small it is. But in Planck, okay, there is always some sort of a lower limit. Pag na-meet mo yung limit, okay, ma-emit na yung energy. Okay? Compared to that one. At ang tawag niya doon ay yung quantum. And then, this explanation was also used by Einstein to solve the so-called photoelectric effect. Okay? You know Einstein? What's the Nobel Prize of Einstein? Is it for the theory of relativity? Saan nanalo ng Nobel Prize si Einstein? Anyone? Doon ba siya nanalo dun sa E equals to mc squared? The answer is no. He won the Nobel Prize because of the photoelectric effect. Okay? So what he did is, he explained yung tinatawag nating photoelectric effect. So this is a phenomenon in which the electrons are ejected from the surface of a metal that is exposed, okay, to light with at least a minimum frequency. So dito, inadapt niya yung concept ni Max Planck. So parang nagiging dual nature na ngayon yung light. So sabi niya, may minimum amount of energy, okay, na kung saan ma-emit yung electron sa metal surface. So ang tawag niya dito yung photon, the particle of light. And if you're going to look at this thing, okay, so inano niya dun yung HB, which is equals to energy. So the kinetic energy plus the W. W is the work function that you have. So you could see that the energy is a frequency of, or a multiple of a frequency. So what Max Planck did is revolutionary during that time, to the point that halos lahat ng research institutes sa Germany at present has a name, Max Planck Institute. Okay? So ang ano naman dito is yung ano nila na yung light as an energy can also have a particle nature. Okay? And they adapt this to solve problems. So meron kayong E equals to HB. And you know, C is equals to B times wavelength, right? So pag ni-replace mo yun doon, if you're going to replace this, so this is what C over wavelength. So E is just equals to H times C over the wavelength. So you can relate the energy with respect to the wavelength. Okay? So if we're going to solve this before tayo ma-kick out, let's try to solve this. So when copper is emitted by a high electrons, when copper is bombarded with high energy electrons, X-ray are emitted. So calculate the energy in joules associated with the photon if the wavelength of the X-ray is 0.154. So we can just use, okay, the value here. And I think I put something here. So it's just the same as that. Pareho lang yan doon. So we know the Planck constant, we know the speed of light, and then we divide all of them with the equivalent of 0.154 nanometer to meter. So you have what? 1 meter, 1 times 10 to the 9 nanometer, and you have that negative value that you have here. And this is just around, if you cancel all the units, ang matitira ay unit ng energy. So question. Tikit pa tayo sa bagay. Tanong. May tanong? Class, may tanong? Yes, Franklin. Nawala.
Hello po. Audible po ako.
Okay, ngayon lang.
Sir, ano po yung standard SI unit po na gagamitin po natin sa wavelength? Meter po or nanometer? Kasi
It
kanina po
depends.
sa example ay okay po.
If you're talking about visible region, you have to use nanometer. Pero pag hindi specified, you can use meter. Kasi yung visible region is in the nanometer, what we call region, or yung unit niya. So makikick out tayo, and then we will continue with the board. Okay? So before what we call, lahat ba kayo nasa chat group na? Sa group chat, sa FB? Everyone there? Tapos lahat ba kayo may access na sa tawag dito, Canvas? Saan bang pangalan yung wala? Malalag ata eh. Is Maladaga. Nandito ba si ano? So, yung ibang wala sa group chat, paano ba? Nag-aano na kami dun eh. And I also posted the link for the recorded video doon sa group chat. So, PM me doon sa thing. Okay? So, I'm just waiting for us to be kicked out. And everybody accomplish yung statement tsaka yung co-requisite. Tinatanong na kasi sa akin eh. So, ang ano daw sa co-requisites, you're taking 18 and at the same time, you should be taking 18.1. So, kung wala kayong 18.1, may problema tayo. Okay? And let me know kung ganun yung situation nyo. Okay?
Sir,
Yep.
pwede po bang humabol ako dun sa agreement? Kasi as of now, naghahanap pa po ako ng lab component for Chem 18.
So, you have to do it as soon as possible.
Okay po, sige po. Thank you.